So we have this finite state machine, which we know is comprised of states, transitions, and then the inputs and events into it. And we came up with this example where we have an AI who is patrolling, running, or chasing at any given time. And there's three events that feed into this: whether or not they see the player, whether or not they're being fired at by the player, or whether or not some time has elapsed. Right. So I think it's worthwhile taking this diagram and then also drawing it in this sort of format, this table format, in which case we would have these three states. We would have patrol, run, and chase. And then our events into this system would be our sees the player, S, fired at, F, and whether or not some amount of time has elapsed. Now, if you are patrolling and you see the player, you're going to move to the chase. If you're patrolling and you're fired at, you're going to move to run. And if you are patrolling and some time has elapsed, you're going to do nothing. If you are running and you are fired at or you see the player, you're going to do nothing. So fired at or see the player. And then if some amount of time has elapsed, you're going to move back to patrol. When you're chasing, if you see the player, you're going to do nothing. If you see the player, if you're chasing and you are fired at, you're going to go into the run state. And if you are chasing the player and some amount of time has elapsed, you are going to go back into patrol. Now, these sort of diagrams, this diagram here, as well as this diagram here, are really common to see in game development. And it's really nice and easy to structure our AI code to take advantage of finite state machines like this. This is one of the reasons why we use finite state machines in AI for games, is because it keeps our code nice and consistent, and it's really easy to debug. And it's really easy to program and to kind of see what it's doing based on all these various inputs. It keeps your code nice and modular, and it's very clear and very easy to talk about, especially with a designer, what the AI for your game is going to do. If I give this diagram or this sort of diagram to a designer or to a set of artists and to other people on the project, they can very easily understand what it is that this AI is going to do in various situations. Whereas if I were to give them some sort of alternative that's some giant messy block of code, it'd be really hard for them to decipher that. So the big takeaways are that with these finite state machines, our AI is in one state at any given time: patrol, run, or chase. It's fed these various events based on the game, whether it sees the player, fired at, time lapsed, and these events can grow and change as our game is being played. And there's these transitions going between the various different states.